Hello everyone. In my previous lecture, in which we were discussing Chapter 3 in A Student's Guide Through the Great Physics texts, Salviati pointed out that Aristotle's theory of falling bodies has some inherent contradictions to it. So remember, Aristotle's theory had two main assertions. One of them is that the velocity of the falling body is proportional to its weight. And the second point was that the velocity of the falling body is inversely proportional to the density of the medium through which it falls. In my last lecture, what we did is showed that by assuming this relationship to be correct, we run into some inherent difficulties. Remember, the idea was that if we take a wooden ball and we drop it in air, so this is a wooden ball and this is supposed to be air, it's going to fall with some speed in air. And then if you take the exact same wooden ball and you drop it in water, it's going to have a smaller speed. And the relationship between these speeds, the velocity in the water compared to the velocity in the air, was equal to the inverse of the densities, the density in air compared to the density in water. That's what this is suggesting. And so that implies that the velocity in the water was equal to 1/10, according to the numbers they were using, of the velocity in air. In other words, if the velocity in air was 20, then 1/10 of 20 would be 2. So if we assume that the velocity in air had a speed of 20, that would imply the velocity in air would be 2, because the density of the air is less than the density of water. What's the problem with that? Well, we know wooden objects, because after all, this is a wooden ball. Wooden objects do not sink in water, they float in water. So Aristotle's theory predicts that a wooden ball will sink in water at a fraction of the speed of the same wooden ball in air, when in fact it floats in water. So there must be something wrong with Aristotle's theory, at least his theory that the velocity goes as 1 over the density of the medium. Okay? But Salviati doesn't stop there with the criticism. He says, let's try something new. We know that a wooden ball doesn't actually fall in water, so try something new. Okay. Wood doesn't fall in water, but something will. So what doesn't fall in water? In fact, it floats. But some object that's going to be maybe denser than wood, but some object will fall in water with a speed of 2. So if these two objects, just to color code them, these are the wooden objects. So that's wood and that's wood. Okay? And there's going to be some other object. Oh, maybe I'll make it yellow. Okay? If I drop, there's going to be some object that will fall in water with a speed of 2. We don't know what it is quite yet. Maybe I'll make it a green object. There's going to be some object that when you drop it in water, it will fall with a speed of 2. So this is the velocity of some other object, O. And that will fall, let's say, with a speed of 2, right? It's going to have to be this object is denser. Must be denser or more dense, have a greater specific gravity than wood. Okay, now, well, so that's maybe point 1. Point 2 is, well, what's the velocity that this object falls in water compared to the velocity with which this object falls in air? Well, that should be, again, if Aristotle's theory is correct, that should go as the ratio of the density of air compared to the density of water, right? Because it goes inversely, the speeds of these objects, if Aristotle's correct, should go as the inverse of their densities. Well, what's the density of air compared to water? Again, it's 1/10. That was the assumption that they're working with. And so what does all this imply? Well, the velocity of the object in air should be equal to 10 times the velocity of the object, I guess this is the velocity object in water, right? Or in other words, it should fall with the speed of 20 in air. So this heavier object falls, according to Galileo's theory, according to Aristotle's theory, with a speed of 20 in air. If it had fallen with the speed of 2 in water, then it would fall with the speed of 20 in air. But wait a minute, I thought we just said that wood falls with the speed of 20 in air. So, but the velocity of wood in air is 20. And I thought, according to Aristotle, the speed of a falling object depends on its weight. It's proportional to the weight, right? Wood is not going to weigh as much as this object here, because after all, it's more dense than wood. So, but we just found that this object, if it falls at the speed of 2 in water, must fall with the speed of 20 in air, which is the same as the speed of the falling wood. So we have a contradiction. So this would, no pun intended, this would contradict Aristotle's point 1. Point 1, this point right up here, that says the velocity of a falling object should be proportional to its weight. Okay? So the upshot of all this is that Aristotle's theory, at least the way that Galileo is reporting it, Aristotle's theory is riddled with inconsistencies or problems. There must be a better theory. And after Salviati spends some time going through these arguments, pointing out the weaknesses in Aristotle's theory, we're about at page 35 in the text right now, and the text reports that Simplicio, who had been defending Aristotle's theory of falling objects, Aristotle's theory of falling objects, Simplicio is then silenced. He doesn't quite know what to say. So let's stop there.